Okay, algebra students, this is the solution set for the Plickers test that we did last week. If you were watching this to complete corrections, you must complete corrections for all of the questions, not just the questions you got wrong. The thinking is if you scored below a 70 on this test, then you need to review all of the questions to make sure you know how to solve them. This won't take very long. We will go through this as quickly as possible. I will show the algebraic solution first, and where possible, we will use the calculator to show how you might solve it on the STAAR. Let's begin with number 1. Jars of sauce are stored in boxes. Each box has 8 jars. A cook uses 2 jars from one box. Write a linear equation representing this situation. So what we're really saying is the number of jars is equal to how many jars in a box is equal to 8 jars times the number of boxes, and then a cook removed 2 jars from one of the boxes, so we have to subtract 2. Right? So that's our equation. Now let's replace the dependent variable, number of jars, with y, and the independent variable, the number of boxes, with x. So y equals 8x minus 2. That's answer choice C. Number 2, write an expression that is equal to the square root of 147. To solve this algebraically, you need to prime factor 147. Okay, what are the prime factors? Well, the quick little trick is you have to think of the prime list: 2, 3, 5, 7, 11, 13. We won't need to go beyond that. So what is the lowest prime factor that will divide evenly into 147? Well, 2 won't work because it's not an even number. So we have to think, how about 3? Now the quick test there is to add the digits. If the digits add up to a number that is divisible by 3, then the whole number is divisible by 3. So 1 plus 4 is 5, and 5 plus 7 is 12. 12 is divisible by 3, therefore 147 is divisible by 3. And a little bit of side work will tell us what that is. 147 divided by 3. 3 goes into 14 4 times. 4 times 3 is 12. 14 minus 12 is 2. Bring down the 7. 3 goes into 27 9 times. So my factors here are 3 times 20, or rather 3 times 49. Okay? Now 49 is not prime. 49 can be broken down into 7 times 7. So my prime factors of 147 are 3, 7, and 7. So what I need to write is a little sentence here. If 3 times 7 times 7 equals 147, then the square root of 3 times 7 times 7 is equal to the square root of 147. Now, the rule about square roots is that each of these can be broken up into pieces. So we take the 2 7s and place them in parentheses because there's something special that we can exploit here. Each of these roots has an index value of 2. There's a little 2 here. That's why we call it the square root. So, you know, we've got square root, which doesn't have an index number because it's assumed to be 2. And then we have like the cubed root, which has an index number of 3. And then the fourth root, which has an index number of 4, and so on. So that's 4, 3, and so the one we're dealing with is 2. Now we're going to exploit something about that. We're going to use that. So we've already written this sentence out. If 3 times 7 times 7 is 147, then the square root of 3 times 7 times 7 is the square root of 147. So we're still writing in English here. Sentences. So the square root of 3 times 7 times 7 is equal to the square root of 3 times, and then what is 7 times 7? 7 times 7 could be written as 49, but it could also be written as 7 squared. 3 times 7 squared. We'll write this. If the square root of 3 times 7 squared is equal to the square root of 147, then the square root of 147 is equal to, and now we're going to break up our square root here. We're going to break it up into the square root of 3 and the square root of 7 squared. The square root of 147 is equal to the square root of 3 times the square root of 7 squared. Okay, so that's a sentence. Now we have another final sentence. If the square root of 147 is equal to the square root of 3 times the square root of 7 squared, then the square root of 147 equals, now we take the square root of 7 squared. The square root of anything squared is just that thing. So the square root of a trillion squared is a trillion. The square root of 7 squared is 7. So we'll write the 7 out here all by itself. 7 times the square root of 3. And we match that up with something from our answer choices, and that would be answer choice B. The algebraic solution would just involve us plugging the square root of 147 into y1. So if you're going to use the calculator, that was the algebraic solution. The calculator solution would say y1 equals the square root of 147. And then you could try y2. This would now be y2, y3, y4, y5. You would have this 3 square root 7, 7 square root 3, 21 square root 7, and 49 square root 3. Let me plug those into our calculator and see the solution. Let me clear the memory. Second plus 7, 1, 2. And go to y equals and put that first thing in, which would be the square root of 147. Go to y2 and start trying a, which is 3 times the square root of 7, down arrow. Next would be 7 times the square root of 3, down arrow. 21 times the square root of 7, yes. And finally, down arrow, 49 times the square root of 3. And if you did it this way, you can just hit second graph and look to see where the y1 values, which is the square root of 147, matches up with one of the other answers. Now, y2 was answer choice A. Those don't match. y3 was answer choice B. They all match, okay? And none of the others match. So it has to be whatever y3 was, and y3 was 3 times the square root of 7, which was answer choice B. Okay, back to the drawing board. This is the algebraic solution, and I want you to know how to do this. But if you can't remember, just use the calculator. All right, problem number 3. Which expression is equal to negative 28 times x squared plus 35 times x? Well, the first thing you need to do is convert this to English. So let's just write it as we read it. Negative 28 times x squared plus 35 times x. Okay. Now, to solve this algebraically, we need to find the prime factors of everything, because what we're going to try to do is actually factor this algebraically. And we're going to do that by first finding all of the factors of negative 28. Okay, we'll do that here. That would be, well, what could you do here? You could do 2 times negative 14, okay, which could be broken down into 2 times negative 7, okay, and then you've got x squared. It can be broken down into x times x, right? And to save my working space here, I'll just move down to the bottom here. 35 can be, think about 35 for a minute. It could be 5 times 7. It could also be negative 5 times negative 7. Okay, it could be either of those pairs. And we want to use this pair because in our negative 28, we had a negative 7. So it's useful to us to choose factors that are common. So we've got, for negative 28, 2 to negative 7. For x squared, we've got x times x. For 35, we have negative 5 times negative 7. And for x, it's just x. Okay? So we'll now rewrite everything in terms of prime factors. So I'll write here, put this in parentheses now, open parentheses, 2 times 2 times negative 7, okay, times x, so that's negative 28 times x squared, plus negative 5 times negative 7 times x. Okay, close parentheses. Now, what we want to do is circle all of the numbers that are common on either side of this plus sign. So think about the plus sign like a dividing wall. What's common on both sides? Let's just circle the numbers. We have a negative 7 here, okay, on both sides. And I also have 1x that's common on both sides. So what that means is I could do reverse distribution, okay, which essentially means divide out. And I'll show exactly what I mean. I'm going to divide this entire expression by negative 7x. And I have to keep this in balance. So over here, I'm going to multiply the whole expression by negative 7x. Okay? Notice I haven't changed anything. This negative 7 would cancel with this. But if I leave it just like this, I can do something cool, which is like reverse distribution. Here, these pairs cancel with the bottom. And now I've got this factored expression. I now have here negative 7x, open parentheses, and we have 2 times 2, which is 4, times whatever is left to the left of that plus sign, which is x, Okay, now write plus, or let's see. On the right side, we have negative 5 times nothing. So I just have negative 5. So it's plus minus. In the epic battle between plus and minus, minus always wins. So it's 4x minus 5, close parentheses. And this is the factored form. And we find that in answer choice B. If you did not know how to do this, you could put this, once you write this out in English, you could put this in Y1 and then check your values. So that's what we'll do right now. We will flip to the screen here and clear out all of our values. Oops. In Y1, we will put negative 28 x squared plus 35x. And then we'll test, again, A would be Y2. That's 7x, open parentheses, 4x plus 5. Okay, and then in Y3 would be B, negative 7x, open parentheses, 4x minus 5, close parentheses. Y4 would be C, that's 7x, open parentheses, 4x minus 5, close parentheses. And 5 would be open parentheses, oops, started too early there, negative 7x. This would be answer choice D, negative 7x, open parentheses, 4x plus 5, close parentheses. Now from this window you need to hit second graph. What we're looking for is for Y1 to match up with some of these other values. So here I've got zeros across the board. How about the next one? I got 7, 63, 7. Okay, so Y3 matches with Y1. All the values match. So whatever Y3 was is correct, and Y3 was negative 7x, open paren, 4x minus 5, which corresponds to answer choice B, negative 7x, 4x minus 5. Okay. Number 4, a drummer and a guitarist wrote songs. The guitarist wrote 8 fewer than twice the number of songs the drummer wrote. They wrote 46 songs. Write a system with D for drummer songs and G for guitarist songs. So we'll start with the lower hanging fruit first. They wrote 46 songs. Well, who are they? The drummer plus the guitarist wrote a total of 46 songs together. Now it says the guitarist wrote. So this other part here, we know it's going to be G equals. So the guitarist wrote 8 fewer than twice the number of songs the drummer wrote. Now this little piece of English right here, twice the drummer is 2D, and 8 fewer than just means minus 8. Minus 8. So there's your system. We just find something that matches up. D plus G equals 46. Okay, D plus G equals 46. D minus D equals, what is that? D minus 46 minus G. That's not right. So I can cancel out C. G equals 46 minus D. Well, you could solve that to be G plus D equals 46. So I can cancel out C. And I'm looking now for 2D minus 8. 2D minus 8 appears in A and nowhere else. So it's A. Guitarist wrote 2D minus 8 and guitarist plus drummer equals 46. Okay, this work needs to be shown. And underline these pieces of the sentence. Number 5, which system has infinite solutions? The key here is to know what infinite solution means. So here are some possible solutions. I'm going to draw these little tiny graphs. Right, let me come in here with my red pen. Okay. And here's another possible solution. And then here's another possible solution. Okay, and then here's another one. So let's analyze these a little bit. This first one is parallel. These lines are parallel to one another. Parallel lines have the same slope. And since slope is represented by the letter M, okay, and we know that y equals mx plus b, anywhere we have m repeated, we have a slope that is the same, therefore we have parallel lines, and a system that has parallel lines has no solutions. So this has no solutions. All right? So here we have one point where they cross. So this has one solution. All right? Here's another system. 1, 2, 3, 4 solutions where these quadratics cross the equal sign, but where they cross each other are right here and right here. So this is more than one solution, but not an infinite number of solutions. This function right here, these lines cross at every single point. So this is what an infinite solution set looks like. So let's go through our, notice here, I just want to make one note. Notice here, these have, this one here, these have different slopes. Okay, so let's analyze our possible choices. For answer choice A, I've got 7x plus 4 and 7x plus 5. The only difference is the y-intercept. The b's are different. But the m values, or the slope values, are the same. Therefore, there's no solution. So that can't be right. Here, I've got linear equations with different y-intercepts and different slopes. That is like this one here. That has one solution. So not infinite, just one. Here, I've got a perpendicular situation, 7x and negative 1/7 x. It's a negative reciprocal slope. Both of the y-intercepts are 0 because there's no b value stated. So again, there's just one solution there, but they're perpendicular to one another. It can't be c. So it has to be d, but why? Well, notice, these are the same lines. They're identical. 7x squared plus 3x plus 5, 7x squared plus 3x plus 5. They match exactly, so when I graph them, they will trace over each other, giving infinite solutions because they're hitting each other at every single point. Therefore, the answer is D. Number 6. What is the range of a quadratic function with a negative slope whose y-intercept is 8? You must sketch. Okay, drawing is required. Okay, I'm thinking of a few students here who love to draw. This should be a fun problem. So create a coordinate plane here with your axes y and x. And let's analyze what we're given. The range of a quadratic function with a negative slope. So we got two possibilities. You've got a hoop shape that looks like this, and you've got a hoop shape that looks like this. Which one is positive? Which one is negative? The one pointing up is positive. The one pointing down is negative. So we want a negative slope. Well, what else do we know about this? We know that the y-intercept is 8, positive 8. So I need 8, and I have no information about the vertex of the function, so I will assume that it is that the axis of symmetry is x equals 0, and that this thing just folds evenly around x equals 0. So the highest point on the graph will be positive 8, and we'll draw a negative sloping quadratic looking curve like that. And now we can analyze this. So what values can this take on the y-axis? Well, it could definitely take on the value 8, okay, because that's there. Can it take on the value 7? Sure. How about 6? Yeah, let's zoom down. How about negative 8? Yeah, can take that value on. It appears that it could take on all kinds of negative values, values below or including 8. Could it take on y equals 9? Could I draw a line up here? No, because it wouldn't hit this line anywhere. So it helps to have like a marker for this. Your solution set for the range will include all values that are less than or equal to 8, like that. But how do I write that in inequality notation? Well, I write negative infinity. This is the range. Okay, so the range y, negative infinity less than or equal to y, less than or equal to the highest value that it can be, which is 8. So the answer choice that corresponds to that is letter D. Okay, and we will move on. Okay, what value of n makes the equation 4 open paren 0.5 n minus 3 equals n minus 0.25 open paren 12 minus 8 n true? Okay, there's a quick way to solve this on the calculator, but I'll show it algebraically since there are some students who want to solve these algebraically. We'll rewrite this. 4 open paren 0.5 n minus 3 close paren equals n minus 0.25 open paren 12 minus 8n close paren. Okay, I want to solve this for n, right? If you're going to solve it algebraically, it helps to turn these decimals into fractions, okay? It really helps. So let me just rewrite this with fractions. 4 open paren 1/2 n minus 3 equals n minus 0.25 as a fraction is 1/4 open paren 12 minus 8 n close paren. Okay, now we have to remember PEMDAS. First word P, which is parentheses. We're going to distribute the 4 to 1/2 n and to negative 3, and then this negative 1/4 will distribute to 12 and negative 8. Okay, so that's what we're going to do next. 4 times 1/2 n is 4 over 2n minus 4 times 3 is 12, minus 12. So 4/2 n minus 12 on the left equals n, and now it's minus 1/4 times 12, which is minus 12 fourths. and then minus negative 1/4 times negative 8, which would be positive 8/4 times n, close parentheses. Oops, didn't need that last close parentheses because we distributed to get rid of it. Sorry about that. Okay, so now we're going to play a little game of combine like terms. But before we combine like terms, it might do us some good to simplify these fractions since they'll all disappear if we reduce them down. 4 divided by 2 is 2, so 2 times n minus 12 equals n. Minus 12 over 4 is n minus 3, plus 8 divided by 4 is 2, 2n. Now we can play combine like terms. So the first thing I'll do is gather these n's together on the left. I've got plus 2n on the end, okay? And what I can do is subtract 2n from both sides. Okay, they both cancel out, just like that. Now I've got negative 12 equals n minus 3. Okay, now I can get n by itself by just adding 3 to both sides. And n will equal negative 12 plus 3, which is negative 9. So if negative 9 equals n, then n equals negative 9. The answer choice is B. If you did not know how to do this algebraically, you take this whole equation, okay, and we're going to break it up right across the equal sign. We're going to put this left side in y1, this guy goes in y1, and the right side goes in y2. Okay, so that's what we'll do now. We will go to our calculator, clear all this out. Up to y1, put the left side, 4 open paren 0.5, change x for n minus 3, close paren. And then in y2, we'll put x for n, x minus 0.25, open paren, 12 minus 8 times x for n. And now that you've got this, you need to graph this and see if you can see the crossing points. Well, we can't see them, so we need to zoom out. We've got to see where these lines cross. Once we see where they cross, we can play a little game. We can play this game called second trace intersect, or second trace 5, to see where those lines intersect, and then first curve, enter, second curve, enter, guess, enter, and then it shows us the intersection where x is negative 9. And x is n, so n is negative 9. That's what we needed. So we'll flash back to our work surface and just confirm that that's in fact, what we found on the calculator. Once again, that would be answer choice B. Okay, number 8. In a sequence of numbers, and then it gives us all these numbers. So it gives us the numbers, it gives us, and then it asks us which equation can find the nth term of the sequence. So it just wants to find a general formula for the sequence. That's really asking you write a linear equation for these coordinate pairs, because we've got this. We've got a sub 3 equal to 0. You have, you've got a sub 4 equal to 6. A sub 5 equal to 12. A sub 6 equal to 18. And a sub 7 equal to 24. Okay. Now this is the cool part. These index numbers, 3, 4, 5, 6, and 7, can be thought of like the x values, and the things that they equal can be thought of like the y values. So we're going to be using stat edit on the calculator to find out what the solution set would be. This would be your L1 column, and this would be your L2 column. all right? However, some people like to learn how to do it algebraically. So it's actually easier on the algebra people working this out algebraically because we can just use two sets of terms. We can just use these first two terms. We've got like two coordinate pairs here, all right? You've got 3, 0 and 4, 6. All right, so this is like x1, y1, x2, y2. Okay, so if I was solving this out, first I would solve for the slope m, which would be y2 minus y1. That's 6 minus 0 over x2 minus x1, 4 minus 3. So that means that m equals 6, because 6 minus 0 is 6, over 4 minus 3 is 1. So m is 6. m equals 6. If I'm solving this algebraically, I can already get rid of b and d. And this is really why I recommend the algebraic solution. Yes, the test is written in a way that you can solve a lot of these on the calculator, but the test is also written in a way that if you solve it algebraically, you save a little bit of time and you see kind of how they came up with their answers. So now what? Well, we can use the point slope formula. Remember, the point slope formula is y minus y1 equals m, open parentheses, x minus x1, close parentheses. This formula is in your reference section on your STAAR test. So now we'll just fill in the values. Y minus y1 is 0. So y minus 0 equals m, which we know is 6, open paren, x minus x1, which is 3, x minus 3. Okay, so now I've got y minus 0. Well, that's just y. Y equals, and now we distribute the 6 through this parenthetical expression to give 6x, and then 6 times negative 3 is minus 18. So I've now arrived at the answer choice algebraically. Y equals 6x minus 18, and we search through and see that that is answer choice C. If you didn't remember how to do this, or you didn't remember that you could do this, you can use the calculator, and we'll do this stat edit stat calc 4 thing to solve it using the linear regression feature. So we'll go to our calculator emulator and click stat, edit, enter on edit, and then put in the L1 column 3, enter, 4, enter, 5, enter, 6, enter, 7, enter. And then go to the L2 column and put in 0, enter, 6, enter, 12, enter, 18, enter, 24, enter. And then it's just stat, calc 4, okay, for len reg ax plus b. Enter, 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 enter through this screen, and you're given the same expression, 6x minus 18, just replacing the a with 6 and the b with negative 18. So we'll go back to our work surface and just confirm that 6x minus 18 is in fact the answer. We're replacing n with the x with an n, so it's C. Okay, number 9. The value of y varies directly with x. I'm going to stop right there and underline and then highlight this phrase, varies directly, okay? Because that is really going to help me out. When I see varies directly, I should be thinking of a butterfly. Okay, I'm not even attempting to be an artist here. But this is the butterfly method. You'll be using the butterfly method. This is something you all taught me. And I used to call it cross multiply and divide, but you call it the butterfly method, and this is really a proportion problem. Okay, so what we'll do is we'll write out what it says. It says y varies directly with x. So just write y over x. And then it says if x is 3, so kind of maintain that format, you know you're going to have something over something equals something over something. So we'll fill in this little template here. X is 3, then Y is 21. What is the value of X when Y is 105? So what is X when Y is 105? Okay, so my people who are playing the butterfly game would multiply 3 times 105 and then divide 21 out of that. Now, if you actually do 3 times 105 and try to divide out 21, it can get a little complicated. So first, let's write out our algebraic expression here. I've got 21 times x equals 3 times 105. Now, without a calculator, there is a cool way you can solve this. You just need to prime factor all the numbers. So we know the prime factors of 21 are 3 times 7, okay, and x is just x. So I've got the left side prime factored. Then I've got 3 times, and I've got a prime factor 105. So what is 105 prime factored? Well, the first number can't be 2 because it's an odd number. How about 3? If the digits add up to a number divisible by 3, then the number is divisible by 3. So 1 plus 0 plus 5 is 6. 6 is divisible by 3. Therefore, 105 is divisible by 3. So I'll write a 3 here. And I need now to divide 105 by 3. You can almost do it in your head. How many times will 3 go into 10? 3 times 3 is 9. So it'll go in 1 time, and that's or it'll go in 3 times. 3 times 3 is 9. 10 minus 9 is 1. Bring down the 5. Okay, so now how many times can 3 go into 15? We used to do this quick method of division. We would write it out like that. We would say 3 goes into 10 3 times. Okay, and then 3 times 3 is 9. So we'd say, well, 10 minus 9 is 1, and we'd put a little tiny 1 right there by the 5 to say 15. So now how many times 3 go into 15? 3 goes into 15 5 times. So it's 3 times 35. What are the prime factors of 35? Well, the lowest prime factor of 35 is 5 and then 7. So 3 times 5 times 7. So we can replace 105 with 3 times 5 times 7. And this turns out to be really, really cool because I can divide, on the left side, I can divide out 3 times 7. It's better if you leave them as factors and then do the same thing on the right. Divide everything by 3 times 7. Now watch how cool this is. You can cancel out the 3's and the 7's on the left, leaving x by itself, so x equals. And then on the right, you can cancel out 1 3 on the top and the bottom, and 1 7 on the top and the bottom, leaving just 3 times 5. Okay, so x equals 3 times 5, or x equals 15. Again, no calculator needed, all right? So if you did not remember how to do that, then my recommendation would be to set this proportion up just like this. Okay, you have it just like this, and then if you really didn't know what to do, there's 2 ways. So some of you will think to do this. You'll have 21x equals 3 times 105. Okay, so some of you will just know to divide both sides by 21, and then you'll have x equals, and then you'll just use a calculator to multiply let's see, here's my home screen. Cancel. All right, you'll take 3 times 105, enter, divided by 21, and you'll get 15. Okay, so if that's how you do it, that's also fine. You could also put the left side in y1 and the right side in y2 and use second trace 5, enter, 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 to find the intersection of those two. Okay, in any case, you'll figure it out. All right, so the answer I should have circled was D, 15. Number 10, which expression is equivalent to x squared minus 17x minus 60? Okay, the first step is always to write out what it said. It said x squared minus 17x minus 60. If we were going to factor this using normal algebra, we need to find two numbers that add to give the middle term, negative 17, and those same two numbers need to multiply to give the last term, which is negative 60. And so what that means we need to do is to find all the factors of negative 60. So what multiplies to be negative 60? Well, negative 6 times 10. Okay, but negative 6 plus 10 is 4. What else? Negative 20 times 3. Negative 20 times 3. Those multiply to be negative 60, and they add to be negative 17. Okay, so good. We've already found it. These are our factors, so we'll just write them in. Negative 20 and 3. Negative 20 and 3. And what we can do is write the factors out like this. Open paren, close paren, open paren, close paren. X and X. Now, X minus 20 and X plus 3. And we just go through and look for that. X minus 20, X plus 3 is answer choice A. If you were going to use the calculator, then we would put all of these answer choices into Y2. Let me make the note. So I would recommend labeling, right? This is Y1, x squared minus 17x minus 60. This is Y2, this is Y3, Y4, and Y5. That way you never get confused. So now we'll go to our calculator, right? And we'll hit Y equals, clear everything out that's in there. And in Y1, we'll put x squared minus 17x minus 60. And then in Y2, we'll put answer choice A, open paren, x minus 20, close paren, open paren, x plus 3, close paren, down arrow, open paren, x minus 5, close paren, open paren, x minus 12, close paren. Down arrow, open paren, x minus 20, close paren, open paren, x minus 3, close paren, and finally down arrow for answer choice D, open paren, x plus 5, close paren, open paren, x minus 12, close paren. And now we can hit second graph and see the tables. And what we see is that Y1 and Y2 match completely. So whatever Y2 represented, which was x minus 20 and x plus 3, that's the answer. So we'll flip back to our work surface just to double check. And we see that x minus 20 and x plus 3 is answer choice A, which matches Y2. And that's how we know that number 10 is A. Okay. Number 11. What are the domain and range of f of x equals negative 37? Well, it helps again to sketch a graph. So if we sketch a graph like this, okay, and we label that graph y and x, and then we graph the function y, or the equation y equals negative 37 right here. Let's call this point negative 37. If you graph that, it's just a straight line on negative 37. So what is it asking? The domain and range. Well, let's see. Let's figure out what the domain is. Domain. Domain, well, this goes off on the x-axis into negative infinity. So negative infinity less than or equal to x. And then it goes to the right into positive infinity less than or equal to positive infinity. How about the range? Okay. The range is negative 37. See, it doesn't go any below or any above. It's flat line at negative 37. Negative 37 less than or equal to y less than or equal to negative 37. Okay, so another way that that's written, we'll see what the answer choices are. So keep this in mind and let's look through the answer choices. A, all real numbers greater than or equal to negative 37. No, it's all real numbers. That's another way of saying all real numbers. Negative infinity to positive infinity. So it's not A. D, or B rather, domain is negative 37. No, we said the range was negative 37. How about C, D, all real numbers? Okay, that's correct. R, all real numbers greater than or equal to negative 37. No, it's just negative 37, not any numbers greater than or equal to. So it's not C, therefore it's D, all real numbers for the domain, and the range is just negative 37. Okay, that's the answer to number 11. Number 12. The graph of f of x equals x squared was transformed to g of x equals x minus 7.5 squared. What happened to the graph? Now, this is more of an analytical question. When we see f of x, okay, and then we see g of x, where there's a shift, okay, g of x equals x minus 7.5. So I've got f of x equals x squared, and then I've got g of x equals x minus 7.5 squared. Okay, so what's going on here? Whenever you see just this part minus something, this is a right shift. Okay, so what's happening is the graph is shifting to the right by 7.5 units. So horizontal shift to the right, 7.5 units. If I'm just doing it analytically, I've already solved it. If you're using the calculator, it is even more visually clear. So this is one where I recommend the calculator, number 12. Let's go in here and clear out all these answer choices. All we're going to do, go up to y1 and put in x squared, okay? And you can look at the graph. Now go back to the y tables, go to y2 and put in, open paren, x minus 7.5, close paren, and then put this little housetop arrow caret thing, 2, to show squared, and then hit graph. Okay, so again, let's zoom in on that and see what's going on. All right, 1, 2, 3, 4, 5, 6, 7.5. So it's shifted right 7.5. And that's how we know that there was a right horizontal shift of 7.5 units. It looks confusing, but when you see the minus sign, it's indicating a right shift, and a plus sign is indicating a left shift. So I'll say minus sign, right, plus sign, left. Okay, that's how you know that. And we're dealing here with a minus sign, so it's moving right 7.5 units. Okay, that's number 12. Let's move on to number 13. A set of weights includes a 4-pound barbell and 6 pairs of weight plates. Each pair of plates weighs 20 pounds. If X pairs of plates are added to the barbell, the total weight can be represented by f of x equals 20x plus 4. What is the range? Okay. So remember that, let's write this, domain is x. and range is y. So here are our y values. Okay, these are different y values. These are y values. So these are range values. And our x values are, we don't know what they are, right? So we're given the range, and we have to somehow figure out which one is correct with our function. Okay, so we can start by plugging in, we can test some values here. So we're given this function, if f of x equals 20x plus 4, then f of 0 equals 20 times 0 plus 4, which equals 4. Right? So my first term is going to be 4. I can get rid of A and C. How about f of 1? Okay, we can write and, it's all a continuous sentence, f of 1 equals 20 times 1 plus 4, okay, which equals 20 plus 4, which equals 24. Well, now I've been able to solve it, right, because the next term is 24, so it's B. Okay, I solved for those two range values. So D's wrong. It's got to be B. If you didn't know how to evaluate these functions, or you were just confused, then just notice that they're giving you a linear equation right there. And what we're going to do is put this in y1. Okay, this is going to be y1. And then we're going to hit second graph to see the tables. So jump over to the calculator, go to y equals, clear everything out. In y1, put 20x plus 4, and then hit second graph. And you'll see the range right there, 4, 24, 44, 64. Jump back to the answer choices, and you see 4, 24, 44, 64. You see that range matches up with what you saw in the calculator, so it's B. Number 14. The area of a rectangle is 54x to the 9th, y to the 8th square yards. If the length is 6x to the 3rd, y to the 4th, which expression represents the width? Okay, so remember, it's giving us something. It's giving us, what is it telling us here? It's saying the area is equal to 54x to the 9th, y to the 8th. And then it gives us the length. Okay, so it gives us the length and the area. So let's remember something. The formula for area is area equals length times width. Okay, and what are we given? Well, we're given the area, and we are given the length. Okay, so we're given two of those terms, and what we want is the width. So how would I get the width by itself in terms of this equation for area? So it's probably not something you've done or not done in a long time. You would divide both sides by length, to get width by itself. So here we've got the length, right? And this, dividing this out, will cancel these lengths here, and we have area divided by length equals width, which is what we want to know. We want to know the width. So we'll now take this literal equation and we'll plug in the values we were given for it. So we were given area and we were given length. So let's plug those into the numerator and denominator over here. So we'll rewrite this. Width equals, and now I'll put a big fraction bar. And on top I'm going to put the area. Well, the area was 54 x to the 9th, y to the 8th. And the length was given as 6x cubed y to the 4th. Okay, make sure that's visible. Y to the 4th. And we're asked to compute the width. So what we need to do here is divide. Now we're going to have to apply our division rule to do this, and we're going to do this in 3 steps. First, we're going to divide the whole numbers, 54 divided by 6, and then we are going to divide the x values, x to the 9th divided by x cubed, and then we're going to divide the y values, y to the 8th divided by y to the 4th. We're going to do it in stages. Okay, so first we have 54 divided by 6, which is 9. Okay, now we have x to the 9th divided by x cubed, which is, the division rule is x to the a divided by x to the b equals x to the a minus b. So x to the a divided by x to the b equals x to the a minus b. Remember that. So I've got x to the 9th divided by x to the 3 equals x to the 9 minus 3, which is x to the 6th. And now I've got y. Okay, again, same thing. Y to the 8 minus y to the 4 equals y to the 8 minus 4, which is y to the 4. So I've now got 9x to the 6th, y to the 4th, and that's the width. Okay, this is the answer. The calculator can't help you on this problem. So the answer is 9x to the 6th, y to the 4th, and that is answer choice C. Remember this rule. If you can remember this rule, you'll be golden on these exponent problems, because they're not that hard. You just have to remember your division rule, your power rule, your multiplication rule, your zero exponent rule. We've gone over those in class, and I think you probably have a good handle on it. Okay, number 15, the halfway point. The total number of seats in an auditorium is modeled by some quadratic equation, 2x squared minus 6x, where x represents the number of rows of seats. How many rows are there in the auditorium if it has a total of 416 seats? So this helps. We need to write x equals the number of rows. Okay, because that's what it said. X represents the number of rows. How many rows are there if there is a total of 416 seats? All right, so what it's saying is f of x equals 2x squared minus 6x, okay? And it's giving us the f of x value. It's saying, what is x when f of x is 416? So it's saying 416 equals 2x squared minus 6x. Now, if you wanted to solve this algebraically, you would need to subtract 416 from both sides and get you a quadratic equation set up that looks like this. 2x squared minus 6x minus 416 equals 0. And the process would be to multiply 2 times negative 416, okay, which you can do it right here, gives us negative 832, okay? And what we would need to find are two numbers that add to be negative 6 and multiply to be negative 832. So we're trying to fill out this little box here. They add to be the middle term, negative 6, and they multiply to be the last term, which is negative 832, or in this term, in this particular problem, the product of the last term and the first coefficient. So that's how you do these problems. You just have to, first you have to multiply the first leading coefficient, which could be greater than 1, by the last term, and you get that negative 832. So now you have to prime factor negative 832, and you have to come up with all the different factors that would give you negative 832 to find the factors that would give you sum of negative 6. So watch how I do this prime factor thing. The first thing I'm going to do is prime factor. And the smallest prime factor is going to be 2 because it's the even number. So we already know it's 2 times 416. And I'm not worried too much about the negative symbols just yet. Now continue to prime factor. Okay, 416 divided by 2 is 208. Okay, then 2 times 104. Break it down some more. 2 times 52. 2 times 26. And finally 2 times 13. Now there's a cool little game I'm going to play here to come up with the factors. All right. So back here, I'm going to write down negative 832. And I'm going to start listing out the possible factors. So first, I need it to be negative 832. So it could be negative 2 times 416. Okay, but those add to 414. So that can't be right. I don't even need to worry about the other possible, which would be 2 times negative 416. Now I'm going to do this little daisy chain mathematics here. I'll multiply 2 times 2, right? So you multiply 2 times 2, and then you multiply that times whatever's to the right of the second 2. So just go with this for now. 2 times 416 equals 832. 2 times 2 times 208 also equals 832. So I could say, well, negative 4, because 2 times 2 is 4. Put a negative in front of it, so I get negative 832 times 208. I'm still not getting anywhere near negative 6 as a sum, because negative 4 plus 208 is 204. And 4 times negative 208 is just negative 204. So not getting anywhere close to negative 6. So I'll keep going with the daisy chain here. Now it's 2 times 2 times 2. That's 8. So write down negative 8 times whatever's next to that last 2, 104. Okay, we're getting closer, but again, we're not getting anywhere closer to having the sum. Negative 8 plus 104 is 96. So we're not getting anywhere closer to negative 6. So let's keep multiplying. So now I've got 2 times 2 times 2 times 2, 2 to the 4th. 2 times 2 is 4, times 2 is 8, times 2 is 16. So now here I've got negative 16 times 52. That's equal to negative 832, but again, they don't add to be close enough to be the factors. So finally, 2 times 2 times 2 times 2, 2 times 2 times 2 times 2 times 2, 2 to the 5th power. That would be 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. And I've got here negative 32 times 26. Now, does negative 32 plus 26 equal negative 6? Yes, it does. So my factors are negative 32 and 26, negative 32 and 26. And now I can factor by grouping. So now I can jump into the second stage, which is factor by grouping. To factor by grouping, what I do is I write, instead of the original, I'll write 2x squared, and then split this middle term. into minus 32x. So we put an x in front of there, and then another x right here. Minus 32x plus 26x minus 416. Okay, and by factor by grouping, what they mean is you're going to group these terms. And now we can continue factoring. So the first thing we'll do on the left is we will factor out the greatest common factors, which in this case would be 2 times x. I could divide on either side of that minus sign, I could divide out a 2x. 2x into x. So now I've got this factor is 2x open paren, x squared divided by x leaves x minus, and then 32x divided by 2x just leaves minus 16. And then over here I've got to factor out the greatest common factor of 416. Now we've actually already got the prime factors of 416. They're isolated right here. See this little area right here? We've already prime factored out all of our 416 factors. So we can play our little game again. What are the factors of 416? What I'm really looking for is 26 a factor of 416? Can I divide out a 26? Well, let's see. So down here, I notice that I've got 26 as one of my factors of 416. So it is, in fact, a factor. The question is, what is 416 divided by 26? Well, the cool trick is you just multiply the 2's. 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. So if I'm factoring this thing, I will divide both of these terms by 26. Okay, and that brings the 26 outside, open paren, and inside I have x minus 416 divided by 26 is 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, x minus 16. Now, with factoring by grouping, once you have these parenthetical factors equal to each other, what you do is you combine these two terms, which I'll highlight in orange, together like this. 2x, and that's a positive 26, plus 26. That's one factor. The other factor is x minus 16. Okay, so the question is, what are the different solutions to these factors? So we just have to set these equal to 0 to solve for them. So 2x plus 26 equals 0, and x minus 16 equals 0. My first, on the left side, I've got minus 26 on both sides. Okay, that cancels there, and then I've got 2x equals minus 26. Divide by 2 on both sides, so I have x equals negative 13. Okay, I can throw out this solution because this solution is negative. All right, and I'm asking for the number of rows. Okay, it says how many rows are there? Well, we can't have a negative number of rows, so this makes no sense, nonsense. So we can toss that one out. So let's just solve for this solution over here. X minus 16 equals 0. We will add 16 to both sides, and you get x equals 16, or the number of rows equals 16. Now this is in fact the solution we are looking for to that quadratic. We just solved the quadratic. It had two solutions. It had negative 13 and positive 16, and we wanted the positive solution. So using nothing but algebra, we came up with 16 as the number of rows, which is answer choice D. Now, let's assume for the moment that you do not remember how to do factoring by grouping, and you don't remember all the prime factoring techniques, and this is just too much for you in the moment on the STAAR test. Okay, how would you solve this? Well, it's actually super quick. So let's start a timer. I don't know how long that took, but I bet it took quite a while. And that was moving at a fairly rapid clip. So let me show you how quickly you can solve this on the calculator. You just need this. And what we'll do is we will go to the calculator. Let me get to y equals and clear out everything that's there. And just put in 2x squared minus 6x. Okay, some of you are going to be mad at me because of how quick this happens. So now we go to second graph. And what we're looking for is the x value when the y value is 416. Because it said 416. So I'm just scrolling, scrolling, scrolling. There it is. So it says x equals 16, y equals 416. It took about a minute. So I am dead set that I'm going to show the algebraic solutions on all these problems. But on this one, the obvious, easier choice was to use the calculator. So as long as you know how to do this, then you can kind of jump to use the calculator when it saves you a huge amount of time, like it did in this problem. And there was also plenty of opportunities to make little mistakes. Personally, this is why I teach math. I absolutely love breaking down these problems. Now, if you absolutely hate it, then please use the calculator, okay? All right, number 16. What is the asymptote of the exponential function? We have to know what an asymptote is, so that's obviously the highlight term. An asymptote in an exponential function is a place where the function appears to just go flat. So I might have a function that goes down and then just suddenly begins to go flat like that. It doesn't really look like that, but it kind of looks like that. So in this case, the asymptote would be whatever this line is right here. So looking at this graph, which one kind of looks like that? And it's real hard to see, even all the way zoomed in. Even on your papers, these letters are small. This is R, this is S, this is Q, Y, X, T. So in this one, the letter S and X are the same line. So the x-axis is represented by the letter S. And so it says, look at your various line possibilities. It's not Q, that's that vertical line right there. It's not R, that's the one most people think, but if you are to plot out the curve, eventually that curve will cross that R axis line, or that R line, which isn't really anything. So because it will eventually cross, it's not an asymptote. Like the definition of an asymptote is a line which the function will never cross. So it will never cross here. And the only place it'll never cross is at line S. So the answer is D. Okay, that was solved a little bit quicker than number 15. Number 17. What is the asymptote of, and then it gives us 3 exponential functions and says, hint, they are all the same. Well, let's first write them out, and then I'll show you a quick trick that demonstrates a principle of exponential functions. So first we're given f of x equals 7, open paren, 1.12 raised to the x. And then we are given g of x equals 215, open paren, 1.76, close paren, raised to the x. And then we are given the last one, r of x is equal to 15, open paren, 1.05, close paren, raised to the x. Okay, and what it wants us to do is put all those into the calculator and see what the asymptote is. And it will demonstrate a principle of exponential functions. See, here's the key, and it wouldn't hurt to review. These are the present values right here, 7, 2, and 15. Those are all the present values. The rates, okay, the R values are 0.12, so 12%, 0.76, 76%, and 0.05, 5%. And the times are all the same. They're x, x, and x. All right, so really there's nothing the same about these equations. So it's like, what could possibly be the same about them? Because it says, hint, they are all the same. Well, let's see what the asymptotes are for all these exponential functions. Let's flash over to our graph and clear this out, and we'll put in 7, open paren, 1.12, close paren, little house or caret top, x, down arrow, 215, open paren, and then 1.76, close paren, raised to the little caret thing, x, down arrow, 15, open paren, 1.05, close paren, raised to the x. And now we'll hit second graph. Notice at x equals 0, the y-intercepts are 7, 215, and 15. And that's one of the features we've all learned pretty well. The y-intercept of an exponential function is its initial or present value, which is whatever number is sitting there before the parentheses, so 7, 215, 15. The question we want to know is, what number can these functions never go under? So we're going to watch these until they all start to tend toward the same number. Let's go into the negative territory on x. Just click up, up, up. Just watch. They're getting smaller and smaller. Y3 is still hanging out there. Smaller and smaller. Notice Y2 has gone into scientific notation, so is Y1. Okay, with that negative value means that it's whatever it is times 10 to the negative whatever. So it's becoming extremely small. So what number does it appear all of these are tending towards? Okay, just think about that. Wait till they're all exponential. There it is. So when you see numbers like this in your calculator, they all mean the same number. Let's look at what those graphs look like. Okay, so a graph like this, it doesn't look like much of anything. But if we zoom out, we hit enter twice, look at the asymptotes of the three exponential functions. Let's zoom out again so you can really see it. Okay, notice that flatness. Boom, all that flatness. What value do these all tend towards on the y-axis? They all tend towards 0. Okay, so this, when they say they're all the same, it means they're all 0. So we'll flash back to our work surface and choose 0 for the asymptote shared by all of these functions, unless otherwise specified. Now we could change the asymptote if we added terms to the ends of these. Like if I put plus 10, this asymptote would now shift up to 10. You know, plus 50, that asymptote is now 50. Plus 100, that asymptote is now 100. It's like shifting the whole function up. But those aren't there Okay, those aren't there. That was just an example. Without any terms on the end, and there are almost never terms on the end, the asymptote can be understood to be 0. Okay, so this is the y-intercept right here. And the asymptote is 0 for those. Number 18. What is the slope of this line? Now, this is an identify question. You have to be able to identify this on the in the quadratic. So the general formula of a quadratic, this is the general formula, or standard form, is f of x equals ax squared plus bx plus c, where a is the slope and c is the y-intercept. Okay, so we are looking at we're looking for the slope. So we're looking for the a value, and the value what we're given is f of x equals negative 5x squared plus 13x plus 4. So the a value here is represented by negative 5. Therefore, the slope is negative 5. The y-intercept is 4. The slope is negative 5. That was an identify question. Number 19. Store A is closing down. Store B is buying all of Store A's inventory. What is the Store B's total combined inventory? What this is saying, when you see the word combine, you should be thinking add. Okay, so we're just going to add Store A's inventory to Store B's inventory. We're just going to add them. And it helps to stack add. So here the solution process is to stack and add like terms. No calculator here, just stack and add. So here we'll take Store A, and we'll write out 1/2 g squared plus 7/2. And then Store B. Here we've got 3g squared minus 4/5g, 4/5 g, plus 1/4. So the like terms are the 1/2 and the 3g squared. Those can be added. And also we can add the 7/2 and the 1/4, assuming we can find a common denominator. So I've already got the things I need to do. I just need to add 1/2 plus 3 g squared. Okay, and then this is all by itself, so it's minus 4/5 g. And then over here I've got plus 7/2 plus 1/4. And I just need to get common denominators and solve it out. Not a problem. So if I want a common denominator with 1/2 for that whole number 3, I can multiply by 2/2. So I'll rewrite 1/2 plus 2 times 3 is 6/2, 6/2 g squared. Okay, close that parentheses, minus 4/5 g, plus, and now I've got to do kind of the same thing. 7/2 need to have a denominator of 4, just multiply by 2/2, and you get, open paren, 14/4 plus 1/4, close paren, right? So now 1/2 plus 6/2 equals 7/2 g squared minus 4/5 g plus 14/4 plus 1/4 is 15/4. So there is your combined inventory right there. All right, so let's find that answer. 7/2 g squared minus 4/5 g plus 15/4. And I see that there in answer choice A. And I won't show all of them, but that is in fact what you need to do. You would have to know to combine those terms. Now there is a simple way to do this in the calculator if you don't want to actually convert these to fractions that share the denominator. Okay, so what you can do is if you go to your calculator and just go to the main screen, you can hit alpha y equals, enter, and put 1/2 plus 3. And that will give you 7/2. So that gives you 7/2 without having to go through this step. And then over here you have alpha y equals, enter, 7/2 plus alpha y equals, enter, 1/4. And that gives you 15/4. So you're looking for 7/2 and 15/4. The one thing I want to remind you is doing it by hand, and it forces you not to forget that minus 4/5 g. It's not plus 4/5 g, it's minus 4/5 g. So just remember that, and one way or another you'll get the answer. Just remember to stack and add like terms, and you can't go wrong. Okay, number 20. What is the y-intercept of the quadratic? This is another identify problem. So there's really nothing to compute. I'm just looking over here and I see that it's crossing the y-axis at y equals 4. So 4 is the y-intercept. There's really nothing else to do there on number 20. So we'll jump to number 21. 21, a particular type of cell doubles in number every hour. Which function can be used to find the number of cells present at the end of h hours if there are initially 4 of these cells? Okay, so what I'm looking for is a rate of growth of 100%. Okay, and I'm looking, here's my present value or initial value is 4 cells. Okay, and the time, t, is h hours. Okay, so what I'm going to do is set up my equation. I've got future value is equal to present value times 1 plus r raised to the t. And I'll just plug in what I have. Future value is equal to present value, which is 4 cells, open paren, 1 plus, now we have to convert 100% into a decimal. That's 1, so it's 1. Open paren, 1 plus 1 raised to the h. So again, future value is equal to 4, open paren, 1 plus 1 is 2, raised to the h. So I'm looking for this. Something that kind of looks like that. Well, looks like future value is represented as n. N equals 4 times 2 raised to the h. That's b. All right, number 21 is b. Got to show this work. What's the y-intercept here? It's 4. Okay, number 22. What is the slope of the line represented by 5x minus 12y equals 24? Now look, This is in standard form. So this is in standard form, and as a result, you must convert from standard to slope-intercept form. We need slope-int form, which is y equals mx plus b. This is currently in the ax plus by equals c form, and we need it to be in this form. So we're going to have to change this equation. So we're going to solve for y. That really means solve for y. So we're given 5x minus 12y equals 24. There's really nothing your calculator can do to help you here. You just have to solve for y. The first step is to subtract 5x from both sides. Okay, and you have negative 12y equals negative 5x plus 24. And now we divide both sides by negative 12. Okay, so down here I've got y by itself equals negative 5 over negative 12 is positive 5/12 x. And then positive 24 divided by negative 12 is negative 2. So it says, what is the slope? Okay, well, the slope is the m value, which is 5/12. This is the slope, or m value. So the answer is D, 5/12. There was nothing the calculator could do to help you there. You have to know how to solve for slope-intercept from standard form. Okay, which expression is equivalent to, and then we're given another quadratic equation that has a leading coefficient greater than 1. So in this problem, if we're going to solve, we'll play that factor by grouping game. And it's giving us 6x squared plus 13x plus 5. So if we wanted to solve this, we would need to multiply 6 times 5, which is 30. So I need two numbers that add to the middle term, which is 13, and multiply to the product of the leading coefficient, the A position, and the number in the C position, 6 times 5, which is 30. So what two numbers multiply to be 30 and add to be 13? Well, let's see. 3 and 10. Yeah, they multiply to 30 and add to be 13. 3 and 10, 3 and 10. Okay. Now, it would be beneficial for me to think about which one I want to list first. Do I want to put the 3 over here with the x squared, or do I want to put it with the 5? Let's just put it how we wrote it and see, because in some of these problems you might have to go back, and I'll explain what I mean as I go along. So we'll now rewrite this thing, 6x squared, and now put plus 3x plus 10x plus 5. And we're going to factor by grouping right here. Okay, so we'll bring this down to this line. I've got open paren. You can't see that. Open paren, 6x squared plus 3x, close paren, open paren, 10x plus 5, close paren. And what I'm trying to do is do like a greatest common factor thing. So in this one, the common factor I can pull out is 3x. See, that's the greatest common factor. So I pull out 3x, open paren, 6x squared divided by 3x leaves x alone. then 3x divided by 3x equals 1. So what I'm really hoping is that when I greatest common factor reverse distribute this term right here, I also am left with an x plus 1. So let's see, what is the greatest common factor there? And that would be 5. Okay, so I've got 5, open paren, 2x plus 1. And that is a problem. It is a problem because I don't have the same number inside the parentheses. So this is one where if you go back to the drawing board and you flip these two, you kind of like switch the positions of these two, you'll see what will happen now. So let's do this again. Let me make a little bit of space here. So let me write, where am I going to put this? Let me write down underneath 24 just what in fact I'm talking about here. So instead of having the 3x here, I'll put the 10x here. Instead of having the 10x here, I'll put the 3x here. And I'll see if I can't write it where you can see it. So it's 6x squared. In this case, I'm going to put plus 10x, okay, and that will be one factor. And then the other factor will be 3x plus 5. Okay? And now I will try to factor this. What is the greatest common factor for this first binomial? What can I divide out of both of them? Well, I could divide out a 2, couldn't I? And I could divide out an x, so I could divide out a 2x. Okay? Right? So I pull out a 2x, open paren, 6x squared divided by 2x leaves 3x, plus 10x divided by 2x leaves 5, close paren. And then I've got this one. There's nothing that I can factor out. Those are both prime numbers. 3x plus 5. So here's the good news. I have these matching factors now. Now because they match, we can write the two. These are the same factor. So we're just going to act like there's only one of them. So now I've got, I'll go back up here now. Let me move all of this back up here. My two factors are 2x and 3x plus 5. Those are my two factors. And as we look for our answer, we notice that there's nothing where 2x is just by itself. Okay? So here's the key. And this is where these problems get a little bit complicated, and it's why I really think the calculator is probably the best solution here. There is actually in front, let me go back down here and show you what I mean. In front of this number right here, there is, in front of this binomial right here, there's this little space, and it's so easy to forget about it. There's this little space right here. So like you say, well, what could I factor out of a prime binomial like this, 3x plus 5? Well, you could pull out a 1. You know, it's almost like a trick. So instead of 2x, I would have 2x plus 1 as one of the factors, and then the other factor would be 3x plus 5. So if you were to FOIL these out, you'd have first, that would be 6x squared outer plus 10x inner plus 3x last plus 5, and that would give you 6x squared plus 13x plus 5. Okay, your original quadratic. So here we would just need to add in that plus 1, which if you ever find yourself with a lonely factor like that that looks like it's missing part of its binomial, you need to go back down and think, could I have pulled a 1 or perhaps a -1 out of that other factor? And that's in fact what had to happen there. So if we're solving algebraically, the answer choice is 2x plus 1, 3x plus 5. 2x plus 1, 3x plus 5 is C. Of course, no one wants to solve algebraically, I'm guessing, on this problem. So what we will do is we will put the original quadratic into y1 and test our answer choices in y2, 3, 4, and 5. And again, I recommend labeling. This is going to be y2, y3, y4, and y5, so we don't get any confusion about what we're guessing on. So this is going to be y1, and we will go to our calculator, go to y equals, clear, go up. y1 is going to be the original quadratic, 6x squared plus 13x plus 5. Down arrow. Now we'll start plugging in. Open paren, 2x plus 5, close paren, open paren, 3x minus 1, close paren, down arrow, open paren, 2x minus 5, close paren, open paren, 3x plus 1. I'm just pulling these answers from the answer choices, and now I'm on to answer choice C. Open paren, 2x plus 1, close paren, open paren, 3x plus 5, close paren, down arrow, open paren, 2x minus 1, close paren, open paren, 3x minus 5, close paren. And now we'll hit second graph and just look at the answer choices. Okay. So I'm looking for 261875, and that's matching up in the pink column, which was answer choice C. Okay, so the pink column and the blue column, y1 matches with y4. This was A, this was B, so y4 was C. 2x plus 1, 3x plus 5. Go back to our main screen, and we see that, in fact, we got the right answer. So, again, it's up to you. These polynomial factoring techniques can be a little bit sneaky and tricky sometimes, and it takes a lot of practice to get comfortable with it. So if you want to use a calculator, that's fine, but if you wanted to show it by hand, then that's how you do it. And again, as you saw, I even had to kind of go and do a switcheroo here in order to get what I was looking for. So you have to know in advance what you want, and then when you don't find it, instead of freaking out, you just go back and switch a couple of terms around and try again. Okay, number 24. Monday, green route 6 times, blue route 5 times, traveling a total of 52 miles. All right, this is going to be a system of equations problem. This is a system problem, and when I see that it's a system problem, I'm thinking matrix. Okay, so we'll write out what we're given, and our template is something box plus something box equals something over something box plus something box equals something. Okay, and then I'll have this little matrix grid that I'll fill out. It's going to be a 2 by 3 matrix. Okay, and the numbers go in there. All right, so let's read it. Monday, green route 6 times, blue route 5 times, total of 52 miles. So I'll use a couple of colors here. I don't have green, so I'll use blue and red. Oh, that's going to be confusing. I'll just use black. Okay, so it's going to be 6 green plus 5 B for blue equals 52. Tuesday, we've got green 12, so 12G plus 13B equals 119. Okay, and it says, what is the length of the green route? Now the matrix solvers would just put 6, 5, 52 right here, and then 12, 13, 119 right there. And we'll come right back to that. But first I want to show how to solve it algebraically. So you have here a system, 6G plus 5B equals 52. And then below that you have 12G plus 13B equals 119. Now I'm going to solve this system algebraically using elimination. Okay, we're going to use elimination. And the way that we do that is we're going to multiply the top function by 2 in order to make the G coefficient be 12. So I'm going to distribute that 2 throughout, like this, to each one. And what this gives me is this new kind of system, right? It's the same system. I'll just rewrite it over here. I've got 12G plus 10B equals 52. And then I've got 12G plus 13B equals 119. And to solve by elimination, I would just stack subtract. Okay, so I'm going to subtract. And when I subtract 12G minus 12G, it cancels out that term. So now, what is 10B minus 13B? Well, that's going to be negative 3B equals, now I need 52 minus 119. Okay, so that's, if I was going to do that by hand, it would be 119 minus 52, 7. Okay, that would be 67. Just want to make sure I still remember how to subtract. Yep, negative 67. So it's negative 67 equal to negative 3. So what is B? You have to solve for B by dividing both sides by negative 3. So this is going to be the blue route answer. So 67 divided by negative 3, if we did that by hand, negative 67 divided by negative 3, 3 goes into 6 2 times. 2 times 3 is 6. So how many times does 3 go into 7? Again, 2 times. 2 times 3 is, that would be negative 6. Okay, and there would be 1 left. How many times does 3 go into 10? 22.9. And it's asking us for the length of the green route. So the blue route appears to be 22.9, and that would continue on for quite a while. It would be 22.9333333 repeating forever. So 67 divided by 3. Oh, sorry, put 9, I meant 3. 22 1/3, so it's 22 1/3 miles is the answer for B. So what you do is you plug that back into one of the equations. So in order to do that, you convert 22 1/3 to an improper fraction. So it's 22 times 3, which is 66, plus 1, which is 67 thirds, and that is now plugged back in to one of your equations. It doesn't matter which one. Just wherever you see a b, you're going to put 67 thirds. So let's see, I'll use this first one. 6g plus 5 times 67 over 3 equals 52. Okay, once we solve this, we'll get g by itself. So what's 5 times 67? 67 times 5 is 5, 3, 33, 335 over 3. So what is, now I've got 6g plus 335 over 3. 3 plus 3 is 6, plus 5 is 11. So that's not divisible by 3. Over 3 equals 52. So what to do? Well, we're going to get 6g by itself by subtracting 335 thirds from both sides. And on the going to have to move some of this over and run out of space here if I'm not careful. Let me make a little bit more work room. Okay, I'm going to move this up. I now have 6g by itself, or 6g equal to, and then I've got 52 minus 335 over 3. And I need 52 in terms of 3, so I'll take 52 times 3, which is 6 and 115. That's 156. So I've got 6g equals 156 thirds minus 335 thirds. Okay, and now I need to subtract 156 minus 335, so more work. 335 minus 156. Okay, going to have to borrow. And that is 9, 7, 2. Let me make sure. 335 minus 156 equals, 1. 2 minus 1 is 1. 179. All right, 179 thirds. So 6g equals 179 over 3. Is 179 divisible by 3? Well, 1 plus 7 is 8, and 8 plus 9 is 17, so no. So now we're going to divide both sides by 6. And when we divide a fraction by a number, we multiply by its reciprocal. So if we're dividing by 6, we are multiplying by the reciprocal of 6. So if I have g by itself, I now have 179 over 3, multiplied by 1 over 6. Okay, so I've got 179 divided by 9. Okay. Let me see here. What have I done? 179 divided by 18. I must have made a mistake somewhere. I wonder where my mistake was. Because this is not working out correctly at all. Okay, well, let me come back to that later. I'll figure that out. Let me show you how to do this on the calculator, and this was kind of a case study and why you would prefer to do this on paper. I think I see the problem right there. I see the problem. I wrote 52, and right there it should have been 104. This was the mistake. This should have been 104. Okay, I'm actually going to barrel ahead and solve this again. Let me use my other copy here. Okay, so just let's catch up with each other back here. Let me set this up again because I just went on a crazy rabbit, chasing a rabbit, and there was no need for that. So let me set this up again. I had 6g plus 5b equals 52. 6g plus 5b equals 52. And then I've got 12g plus 13b equals 119. 12g plus 13b equals 119. And if we're going to solve this using elimination by subtraction, we need to multiply all the terms in the top equation by 2. So we distribute the 2, right? And this time we're really going to make sure that we do it correctly. So let me just rewrite those two. That would be 12g plus 10b equals 104. And underneath it, I've got 12g plus 13b equals 119. All right, and now we're going to solve using elimination by subtraction. So we're actually going to subtract these. And the reason we do that is because 12g minus 12g cancels out, and now we can solve for one of the variables, b. So 10b minus 13b equals negative 3b equals, and now 104 minus 119. Well, 119 minus 104 equals 15. Okay, so if I now divide both sides by negative 3, I should get b equals negative 5. Okay, and so now what I'll do is plug in negative 5 everywhere I see a b to solve for g. So 12, oops, I don't have to use 12. I can use this simpler function, which would be this top one. You just pick one and plug it in. You have 6g plus 5, open paren, negative 5, equals 52. And so we now have 6g plus negative 25 equals 52. And we can add 25 to both sides. And on the left, they cancel out, and I have 6g equals to 77. Okay, so now I just have to divide both sides by 6, and I get g equals, now I need to divide 77 by 6. So let's see, 77 divided by 6. 6 goes into 7 one time. Yeah, this isn't going to work. Somehow that didn't work. Somehow this needed to be, oh, I see what's wrong. This should have been negative 15, and that would have given me positive 5, positive, positive, and then this should have been negative. My bad. So we'll just correct this small error. So 52 minus 25 would be 27. 27, not 77, 27 over 6. And see, 6 goes into 27. How many times does 6 go into 7? 6 goes into 7 one time. Or 6 goes into 27. How many times does 6 go into 27? 6 goes into 27 4 times. Okay, so that would be a 4. 4 times 6 is 24. 3, okay, bring down a 0. So it's going to be 4 point something. 6 goes into 35 times, so it's 4.5. So the answer is 4.5. And that is B. Rather, it's, apologies, it's G. So G. G equals 4.5 and B equals 5. So G equals 4.5 and B equals 5. Now, that means the answer is, for the green route, it is 4.5. Now, if you wanted to solve this using your calculator, what we would do is we would go back to our other problem and plug this into the matrix editor. So in the matrix editor, let's flash to our calculator. We're going to plug these values into the matrix editor, transition back, and click on second matrix. And we want to go right arrow, enter, and we want to get a 2 by 3 matrix. And then fill these values in. 6, enter. 5, enter. 52, enter. 12, enter. 13, enter. 119, enter. And then hit second quit, and now hit second matrix, right arrow one time, and go down until you get to letter B for RREF. Click enter one time. Then hit second matrix again, and then enter, enter. And that gives you 4.5 and 5. 4.5 goes with whatever came first, which in this case was the green route, and 5 goes with the second thing, which is the blue route. So for that reason, 4.5 is the green route length, which just confirms what we found using the more tortuous elimination by subtraction method. Okay, and so sorry about the mistake. It does happen. I've now been trucking along for over 2 hours on this, so I guess I'm getting a little tired. All right, so on number 25, we are given height data and length data. Identify and describe the correlation coefficient. Okay, so the first thing is we have to understand that height is going to be L1. Okay, length is going to be L2. So what I'm going to do is go into stat edit and put in all those values into L1, and then in L2 I'll put all those length values. So height is L1 and length is L2. Before I do that though, I need to turn on stat diagnostics. So let me show you what I mean, because when I see correlation coefficient, what I need to do is turn on stat diagnostics, and that's under second mode. Or no, it's just under mode, not second mode, just under mode. It's just under mode, and then you scroll down and turn it on. Like on this calculator, you just hit mode, and you go all the way down here and turn on stat diagnostics. Okay, and then you go to stat edit, and you enter in all of your values, which in this case are, we'll just do it on this calculator, 41, 70, 21, 34, 10, 92, 54, 24, 10, 35, 42, 66. Oops, 66. All right, and then the L2 column, it's just 21, 25, 32, 12, 16, 45, 40, 23, 45, 35, 21, and 14. Okay, make sure you have the same number of rows, which we do. Okay, so now that we've done that, we can hit Stat, Calc, 4, enter, 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 enter. And it's going to give us an R value. So we're looking for the R value, which is 0.155. So R, not R squared, not R2, nothing, just R equals 0.15. I mean, look, this is the answers they give us. So it was positive 0.15. Now we have to interpret that. So our correlation coefficient diagram looks like this, where the maximum value is positive 1, the minimum value is negative 1. And halfway down, it's 0. Okay, and then we have these midpoints here. We got 0.5 and negative 0.5. So if it's in this range here, it's strong positive correlation. If it's in this range, it's weak positive correlation. And here it's weak negative correlation, and here it's strong negative correlation. So where does ours come in? Ours is 0.15. We plot it in like a slope. So ours is going to come in somewhere. This is our correlation coefficient, is going to be somewhere in this area right here. So this is 0.15, and that is a weak positive correlation. So what we're looking for here is 0.15 weak positive correlation. That's answer choice A. Okay. Number 26. The population of Center City is modeled by exponential function f, where x is the number of years after 2015. The graph of f is shown on the grid. Which inequality best represents the range of f? Okay. So the bottom row here says 20, 40, 60, 80, 100. Those are years after 2015. So the 0 here actually represents the year 2015. So the y-intercept right here is 250,000. And what is it asking me? Write an equation, or what is the range? Okay, so the range is y is greater than or equal to 250,000, because that is the starting value. It's incorrect to put an upper limit on this exponential function because it doesn't tell us there. It has an end cap with a little arrow saying that it goes on forever. So the full inequality would be 250,000 less than or equal to y less than or equal to positive infinity would be the full range. But the only one that actually makes any sense is letter B. Okay, and so that would be the answer choice. That was more of an identify problem. Okay, number 27. Number 27, a sequence can be generated using A sub n, let's write this down so it's clear. A sub n equals 4 A sub n minus 1, where A1 equals 6. So A1 equals 6. And n is a whole number greater than 1. Alrighty. what are the first four terms of the sequence? Well, this looks really complicated, but here's what I want to point out to you. There are only two numbers in the problem, 4 and 6. So if you multiply 4 times 6, you get 24. All right, so what would the next number in the sequence be? If A sub 1 is 6, then A sub 2 would be let's see here, 24 minus 1, 23. Look in the, if we go to your y equals and put in y equals 4x, and then we hit second graph, we see 24 and we're looking for values that show up in the range. So I see 24 showed up, 96 showed up, and I'm guessing 384 would show up. There's no need to scroll all the way down. The answer is B. So these are, in other words, whatever, like they have to be multiples of the initial value. So in that one, I would just say multiply 4 times 6, and the moment you did that, 24 was the only possible answer choice, and that narrowed it down to B. Number 28. Ruby can choose any combination of X roses and Y carnations, and she does not want to spend more than $30. If roses cost $3 each and carnations cost $2 each, which inequality represents all combinations of roses and carnations? Okay, so this is a linear inequality problem. And for a linear inequality, we're going to have a less than or equal to sign in there because more than is leading me to believe that she doesn't want to spend any more than her maximum budget of 30. So roses cost 3, so it's 3R plus 2 times carnations, 2C. So we'll replace the R's with X. 3X plus 2Y less than or equal to 30 is the linear inequality. 3X plus 2Y less than or equal to 30. And the only choice is B. Okay. Number 29. A river's water level was measured for 2 weeks. The graph models the linear relationship between the water level and the number of days. Which statement best describes the y-intercept of the graph? Okay, so, well, at number of days equal to 0, the water level was at 16. So 16 is the present value, okay, or the initial value. Let's see. The water level increased, the maximum water level, the initial water level was 16 feet. So there it is. You just circle the one that makes sense because that's what the y-intercept is. Okay, 29 is done. And finally, number 30. There are 1,024 players in a tennis tournament. Each round, half the players are eliminated. What function can be used to find the number of players? All right, we just have to remember that future value equals present value times, now we have to think about this part. Is this an exponential growth problem or an exponential decay problem? Well, here's the difference. So this is growth, and this is decay. We'll put both of them down. Growth would be future value equals present value times 1 plus r raised to the t. And decay is future value equals present value times 1 minus r raised to the t. So which one is it? It says they're eliminated, so by using this language eliminated every round, it says half the players are eliminated. I can say, well, this is probably a decay problem, so I need to use this equation, 1 minus r raised to the t. And now I can fill in what I know. I know that the future value is unknown. It's equal to the current value of players, which is 1,024. Okay, that doesn't help me because they all have that initial value, times 1 minus, now we have to represent half is going to be equal to 0.5. So 0.5, in other words, they decrease by 50% every time, raised to the t. So that's future value equals 1024, open paren, 1 minus 0.5 leaves 0.5, close paren, raised to the t. The answer choice that fits that description is B. That shows that they decrease by 50% each round. Okay, it's been a long, hard battle, 2 hours and 20 minutes on the clock. But we have gone through all 30 problems, and we have solved them where possible using algebra, and where it isn't possible, we use the calculator. And wherever possible, we used both methods. So please make use of this video to help teach you how to do it. And in the case of the elimination question on number 24, how to make enormous mistakes and get bogged down in the weeds. And it kind of helps ramify where the calculator can sometimes save you from your own exhaustion or carelessness. As we saw, just forgetting to distribute that 2 to the 52 right there, screwed everything up on that one problem. So what a crazy experience, and I hope you enjoyed the ride, and I hope you learned a lot. So good luck, and thanks again.